Thanks for tuning into class again today. We're going to keep going on chapter 7, so this will bring us to part 2 of this 3-part series. Where we left off last class was we had a concave utility function. There's some probability a person would get sick. If they did get sick, they'd get a low sick income that corresponded to a low utility level. And if instead they stayed healthy, they'd get a higher healthy income that corresponded to a higher utility level. Since there was uncertainty as to whether the person would get sick or stay healthy, they just had to take their probability of getting sick and use it to inform them whether they should position themselves closer to dot A or to dot B on the running path between dot A and B. And where they were on the path gave us their expected income and their expected utility. Again, expected income and expected utility were not values that the person actually realized. They are just weighted averages, the two possible alternatives. Okay, now we're going to do some mental gymnastics. What I want you to think about is, what does the star that is now on the figure mean? Note that it's stacked on top of the person's expected income, but it's on the utility function. Okay, the star is going to be the utility a person would get if they actually got the expected income. In other words, if you gave the person the intermediate level of income that was the weighted average of their two possible alternatives, then getting that intermediate level of income would make them that happy or would give them that many units of utility. Okay, in case you didn't catch what just happened, there is magic that just kind of occurred. So let me give you a concrete example. Suppose you have a person whose sick income is 0 and their healthy income is $50. Okay, let's also suppose that an income of 0 would give a person 0 units of utility, and an income of $50 would give a person 10 units of utility. If a person has a 50% probability of getting sick, or their P is equal to 0.5, then there's a 50-50 chance that they'll end up at dot A or B. So they'll position themselves smack dab in the middle of the path, and their expected income will be $25. Accordingly, their expected utility will be 5. So if you think about this person living multiple time periods, and during each time period, either they land on dot A or they land on dot B, in other words, either they get sick or stay healthy, then at the end of their life, their income would average out to $25 if they're bouncing between income levels of $0 and $50. And also at the end of their life, their utility would average out to 5 if they're bouncing between utility levels of 0 and 10. Okay, what we learned from the star is that if you have this person, but instead of making them bounce, if in every period you gave that person exactly $25, then in each period of their life, they would realize a utility level of 8, which would end up averaging out to 8 at the end of their life. So without really making this person any richer, we increased their utility. And we did that by just stripping out the volatility in their income. This thing that we just observed reveals that people are risk averse. In other words, riskiness or uncertainty in a person's income causes that person's utility to be lower than what it would otherwise be if you gave them a fixed amount of income every period. So in this utility income model, we see that individuals prefer a certain outcome to an uncertain outcome with the same expected income. Another way of expressing this is UEI is greater than EUI. Very succinctly, all of this just means that an individual is risk averse. Okay, now we're really going to do a mental backflip. So what I want you to think about now is, what is the difference between a person's expected utility and the utility they would get from an expected income conceptually? Or in other words, conceptually, what is the vertical distance between the position of the star and the position of the man along the path? that distance is like the utility deficit that emerges due to the existence of uncertainty. In other words, it's equal to how much utility the individual is forfeiting by bouncing between two income levels instead of just sticking the same income level every period. Okay, let's think about the size of the deficit. So kind of fix your gaze at a particular location along the horizontal axis, and that's going to correspond to a particular income level. Okay, at that position, just lift your eyes, and at some point your eyes are going to hit the diagonal path, and then if you keep going up, your eyes are going to hit the utility function. Okay, the gap between the utility function and the diagonal path, we're thinking of that as a utility deficit that exists due to uncertainty. But now we're thinking about how large that gap is. And how large that gap is depends on several things. So to demonstrate this, I'm going to walk you through a few thought experiments. So first, suppose we have a person who has a P equal to 0.5. What that means is that the person has a 50% chance of getting sick. So their expected income is going to be smack dab in the middle of IS and IH. So if you fix your gaze at the midpoint between IS and IH and then lift your eyes, what you will see is that at that location there's a pretty big gap between the star and the path. Intuitively, this should make sense. So if P equals 0.5, that means there's like maximum uncertainty in a person's life. They have no sense whatsoever as to whether they're more likely to get the low income IS or the high income IH. So, in other words, because there's so much uncertainty in their life, if you erase that uncertainty, there's a lot of utility to be gained. Hence, the utility deficit is going to be quite large when P equals 0.5. Okay, what would happen to the utility deficit if P went up from 0.5? That would mean that the person is more likely to end up being sick. And consequently, there's actually less uncertainty in their life, and what we would end up seeing is that their expected income would fall a little bit. So you would take their expected income and you would shift it left relative to the midpoint that it'd be sitting at if P equals 0.5. Okay, so P has just increased, and now that P has increased, expected income has shifted to the left. Now fix your gaze at some new expected income, which is smaller than it originally was. And then, again, trail your eyes up. Okay, the new vertical distance between the path and the utility level has just shrunk relative to where it was last time we were thinking about this. Okay, pause for a minute and think about how this lines up with what we'd expect if we didn't know economics and we were just trying to mentally untangle this. Well, if you have a 50% chance of getting sick, again, that means you have maximum uncertainty in your life. You have no sense as to whether you're more likely to get sick or stay healthy. So you've got lots and lots of uncertainty. And we know people don't like uncertainty because they're risk averse. And so if you take away the uncertainty, that makes them happier. So in other words, there's a big gap between the path and the utility function of P equals 0.5. But then if you take a person as a coin toss in terms of whether they're going to get sick or stay healthy and tell them, okay, now you've got a 90% chance of getting sick. So your P just increased by a large amount. Well, what does that mean? That means, again, the person kind of has less uncertainty in their life. Now they know that more than likely they're going to get sick. And so since they don't have as much uncertainty in their life, they have less to gain by reducing the uncertainty because there's not as much uncertainty to begin with. So as a result, the utility deficit from erasing the uncertainty is kind of small. Okay, now let's just back up and think about this in reverse to especially kind of let it set in. So let's go back to a person having a 50% chance of getting sick. The next thought experiment is what would happen to the utility deficit if you took this person's P and you lowered it from P equals 0.5 to a smaller value. Well, if you have a lower P, that means you have a lower probability of getting sick. That means that chances are you'll probably end up healthy. So the first thing that would happen is the person's expected income would rise. And if expected income drags over to the right, then the utility deficit would again fall because the gap between the path and the utility function would be smaller when expected utility moves up from the midpoint. Again, the intuition should hold. So if you're starting out with a 50% chance of getting sick, lots of uncertainty in your life. You don't know what's going to happen. If from this position a P value is lowered, so maybe it goes down to 0.1, well, now there's less uncertainty. More than likely you're going to stay healthy because you have a very small chance of getting sick. So that means the amount of extra utility you could get if you washed away that uncertainty from your life, it isn't quite as much as it was before because there's not as much uncertainty to wash away. Okay, introduce insurance. So here's where insurance can kind of help us realize this magical property of us getting happier when uncertainty is erased. Okay, so what we're going to do now is we're going to try to set up an insurance contract such that the person will just know certainly what income they're going to get, and we're going to set it up such that the income that they're certainly going to get is going to be their expected income. In other words, we're going to construct an insurance contract such that the person will definitely realize the expected income, because as we've just shown, if you realize the expected income, then the utility you get from the expected income is quite high. Okay, so in other words, in this new situation, there's going to be no uncertainty, there's going to be no jumping between two extreme income levels. The person is just going to know that no matter what happens to their health, they're going to get the expected income, and that's just the way their life's going to be. So no uncertainty whatsoever. Okay, here's how the insurance contract will be set up. If a person buys this insurance contract, then they're going to pay an upfront cost. We're going to call this the premium, and we're going to say the premium is denoted by R. So regardless of whether the person stays healthy or gets sick, they're going to pay R. Okay, in the event the person does get sick, the insurance company is going to give them a payout. We're going to denote the payout with Q. Now, if the person doesn't get sick, the insurance company is not going to give them the payout. So the Q is only given to them in the event they get sick. So you can think of the payout as something similar to a coupon that the person would get to cover their medical bills. So if you get this Q or payout, you really don't have to pay anything extra out of pocket for your medical bills. The insurance company just picks up the tab effectively because they've just given you the money you need to cover the bills. Okay, this means that there are going to be two new possible income outcomes. Okay, first in terms of notation, if you see a prime anywhere, that's going to indicate that we're thinking about a situation in which the person has insurance. So IS prime will be the income the person has when they're sick and they're insured. Okay, given what I've just explained, a person's income when they are sick and insured will be their original sick income minus the premium plus the payout they get when they're sick. On the other hand, their income when they're healthy and insured will be their original healthy income minus the premium. And that's it. There's no payout because they're not sick. Okay, recall we want this contract to be such that it eliminates uncertainty from a person's life and they get their expected income if they're sick, and they also get their expected income if they're healthy. So in order for the insurance contract to work this way, what we need is for their expected income to be equal to the person's income if they're sick and they're insured, and for this to be equal to the person's income if they're healthy and insured. So we can take what we know and we can plug it into that equality and solve for the necessary premium and payout. Here's what we know. EI is equal to P times IS plus 1 minus P times IH. And we know that IS prime is equal to IS minus R plus Q. And we know that IH prime is equal to IH minus R. First, we can take the two last terms and use those two terms to solve for Q. So in your notes, just fill out the following math that I'm going to put up on the screen. Step 1, we can take the negative R from both sides and drop it. Step 2 is we can move the IS to the other side. And what this gives us is Q equals IH minus IS. Voila, we just solved for the payout. So this is what the insurance company needs to give their customers in the event they get sick. Okay, what do they need to give them? They need to give them IH minus IS. In plain English, that means that if this insurance contract is going to work to wipe the uncertainty from a person's life and give them their expected income regardless of their health, then what needs to be true about the payout is that it needs to equal their income that they were previously getting when they're healthy minus the income they were previously getting when they are sick. Think about what that difference is. When you're uninsured, the difference between the income you have when you're healthy and when you're sick is just how much your medical bills are. So in other words, Q, or the payout, needs to equal the guy's medical bills. So if you go back to the example of the coupon needs to exactly equal what your expenses are. The coupon should not be any more than that. It should not be any less than that. The payout needs to exactly equal your medical expenses. Okay, now we can go back to where we started and we can take the two outside parts of the equality and use those to solve for the premium R. Step 1, we can simply distribute. Step 2, we can factor out the P and move the IH to the front when you're looking at the left-hand side. Step 3, recognize that we just solved for Q, and Q equaled IH minus IS. So wherever we see the IH minus IS, we can just plug in a Q. Step 4, we're just going to move things around to solve for R. So what we get is R equals P times Q. In plain English, what does this mean? It means the premium should be equal to the consumer's probability of getting sick times the payout they'll get if they get sick. All right, let's do one final thing before I let you loose. Let's just verify that there's absolutely no uncertainty in this person's life if they buy an insurance contract that has this particular premium and payout. Okay, let's start with what would happen to the person if they stayed healthy. If they stayed healthy and had this insurance contract, again, their income when they're healthy and insured would be IH minus R. And we said R was equal to P times Q. So in the place of R, we can just plug in P times Q. We said that Q was equal to IH minus IS. So in place of Q, we can simply plug in IH minus IS. We can then distribute the P. After this, we can move the P times IS to the front, and then we can pull out the IH from the other two terms. Or in other words, this is like the reverse of distributing. We're undistributing. Okay, what do we get? We get that the person's income when they're healthy and insured will be P times IS plus 1 minus P times IH. Okay, just think for a minute. Does this look familiar? It should, because this is expected income. Okay, so far so good. So this means that if a person has this insurance contract, then if they stay healthy, they'll get the expected income instead of their original IH. Okay, now what happens to the person if they get sick? If they get sick and they have this insurance contract, their income will be IS minus R plus Q. From this, we can take the R that we solved as being equal to P times Q, and wherever we see an R, we can just plug in P times Q. Then we can take the Q that we just solved as being equal to IH minus IS, and wherever we see a Q, we can just plug in IH minus IS. From there, we can distribute the P. Then we can cancel out the positive IS and the negative IS. Finally, that just yields P times IS plus 1 minus P times IH. Okay, this time did you catch what we just solved for? Again, this equation is exactly equal to expected income. So in other words, if a person buys this insurance contract and they happen to get sick, what will their income be? They'll get their expected income. They'll get that intermediate level of income instead of what used to be dot A. So now we know how to magically generate happiness. All we have to do is we have to set up an insurance contract where people pay money up front. Specifically, they pay P times Q. And then in the event they get sick, they get a payout. Specifically, the payout needs to be the difference between their original healthy and sick incomes. And if you do that, then the income volatility will just be entirely erased from their life, and they'll be guaranteed to always land on the star instead of bouncing between the two extreme dots, A and B. And so in this way, insurance kind of has this feature of magically generating more happiness without actually making any more money. There's no more money in this model. We've just taken the volatility and erased it by giving a person a fixed intermediate level income instead of letting them bounce between two extreme income levels with uncertainty. So with that, ask all your questions and I'll try to answer them in the next 10 minutes, and then after that we'll come back to do the exercise. For the exercise today, I'm going to have you answer 2 questions, and the purpose of this is to have you practice solving for R and Q. So the scenario I want you to think about is, suppose a person has P equal to 0.6. If they get sick and are uninsured, their income, IS, is $10,000. If they stay healthy and are uninsured, their income is IH equal to $50,000. The first question is, what premium would an insurance company need to charge this person so that their income when they are healthy or sick and insured is equal to their expected income? Question number 2 is, what payout would an insurance company need to give this person so that their income when they are healthy or sick and they're insured is equal to their expected income? So for question 1, you're solving for R, and in question 2, you're solving for Q. Once you have 2 numbers, submit those, and that will be it for the day.